Hello friends, my name is Ashwini Dinesh Chandra Sharma. I am studying at Adarsh College, Hingoli. Here I am explaining solution of homogeneous equation. To understand homogeneous equation, first of all, we must know the difference between order of differential equation and degree of differential equation. Then, if the sum of order of every differential coefficients is same, then the equation is called homogeneous equation. Let us learn how to find the solution of homogeneous equation. Homogeneous equation can be put in the form dy upon dx is equal to f1 of xy upon f2 of xy, where f1 and f2 are expressions in homogeneous form and of same degree in x and y variables. Put y is equal to vx. On differentiating this, we get dy upon dx is equal to v plus x into dv upon dx. Put this value of dy upon dx in equation 1, we get v plus x into dv upon dx is equal to f of v. Here, f of v is the function of x and y but in the form of v. As we replaced f1 and f2 by putting y is equal to vx, then x into dv upon dx is equal to f of v minus v. On separating the variables, we get dv upon f of v minus v is equal to dx upon x. This gives relation between v and x. On putting v is equal to y upon x, we get the relation between x and y, which satisfies the original equation, and that is the solution of given homogeneous equation. In short, to find the solution of homogeneous equation, we have to perform these 5 steps. Check whether the equation is homogeneous. If it is homogeneous, substitute y is equal to vx. Then separate the variables, integrate the current equation and substitute the value of v. We will get the solution of equation in the form of x and y. Let us take an example. Solve x square plus y square into dx minus 2xy into dy is equal to 0. Here, the given equation is homogeneous as order of its every differential coefficient is 2. Then, put y is equal to vx. On differentiating, dy upon dx is equal to v plus x into dv upon dx. The given equation can be written as dy upon dx is equal to x square plus y square upon 2xy. Thus, equation becomes v plus x into dv upon dx is equal to x square plus v square into x square upon 2x into vx. The x square get cancelled from numerator and denominator as it is common in both. Implies v plus x into dv upon dx is equal to 1 plus v square upon 2v. Implies x into dv upon dx is equal to 1 plus v square upon 2v minus v. Take the LCM, we get x into dv upon dx is equal to 1 plus v square minus 2v square upon 2v. That is, x into dv upon dx is equal to 1 minus v square upon 2v. On separating the variables v and x, we get 2v upon 1 minus v square into dv is equal to dx upon x. Integrate this equation, we get log of c minus integration of minus 2v upon 1 minus v square into dv is equal to integration of dx upon x. Here, negative sign is adjust so that we get the derivative of 1 minus v square in the numerator. Thus, log of c minus log of 1 minus v square is equal to log of x. Implies log of c is equal to log of x plus log of 1 minus v square. According to the logarithmic property, that is log of a plus log of b is equal to log of ab, we write log of c is equal to log of x into 1 minus v square. On taking the antilog, we get c is equal to x into 1 minus v square. This equation is in the form of x and v, but to get the solution, we have to transfer the equation in the form of x and y variables. Thus, put v is equal to y upon x and we will get cx is equal to x square minus v square. On writing it in standard form, we get x square minus y square minus cx is equal to 0, and that is the solution of given homogeneous equation.